what are the physical differences? Let's just run this down. The physical differences between a biosimilar and a generic.
So to start with, there are different ways that they're made. Biosimilars are made in host cell lines, whereas the generics are small molecules.
Okay. So one is alive, one isn't.
Correct.
That's a huge difference. Right?
Exactly.
It's not that, oh, I know where this carbon goes and where this oxygen should be. It's, I'm going to grow this and it should work the same, right?
Well, yes and no, Peter. I mean, what I'm sure we'll develop in a few minutes is that the primary structure, the sequencing of the amino acids has to be the same for a biosimilar and for a biooriginator.
That's important.
Yeah, yeah.
That's good.
But it's the tertiary structure, the afucosation, all different variations which may occur. It's a different chemical overall tertiary structure that makes it a difference.
And I think you said that they were grown, not manufactured.
Well, that's where a lot of the variability can occur. So during the manufacturing process, when the cells are making the product, we get changes to the secondary, tertiary, even the quaternary structure. Now, those changes have to be very, very small so that, in fact, the biosimilar will behave exactly like or highly similar to the reference product. But we've learned a lot about this because we've learned so much about manufacturing biologics over the last 30 years. And thus we can control for these things, but more importantly, we can actually test for the variability to assess that any of the variability that occurs doesn't change how the product actually behaves.
I mean, I had this image when you said that of the cells not listening to what you tell them. They're going to do what they want to do.
Well, that's true.
And the trick is to make the cells do enough to make this behave well. Is that fair?
That's fair. And the other process is that manufacturing these products has improved so much in the last 20 to 30 years with much better scale up, much more efficiency of production, that all that technology has now allowed us to reverse engineer these products.
Okay, and now we've also got the issue of stability.
Right.
Right. These are biologicals. These are not pills that you put in the, I hesitate to say in the medicine cabinet in your bathroom because you shouldn't put pills there. But they're different. They're not as stable, are they?
No, they're not, or they can be, or they might not be, depending upon
the molecule. Well, there's a definitive statement
for you. Well, it depends on the molecule that we're talking about.
Okay.
But the working definition is that there can be differences in the molecule between a biosimilar and a biooriginator, the reference molecule, but they can't be clinically meaningful. They can't affect the safety. They can't affect the efficacy. They can't affect the purity or the potency of the molecule that we're dealing with.
So we're focusing on end effect as opposed to absolute mirrored structure.
Right, exactly.
Okay, and what are we dealing with in terms of immunogenicity potential?
Well, essentially, chemical products really have very little, if any, immunogenicity, but all biologics are immunogenic, and they're different in different people. And what's been interesting about the biosimilar process is that we've actually learned a lot more about immunogenicity of both the biosimilar and the reference product, because the assays that we're using now to detect immunogenicity are much more sensitive because they're much more modern.
So the bar is actually higher.
Yes, it is.
Because we can examine things in more detail.